Kruskal-Wallis test. Kruskal-Wallis test is a non-parametric test, which is very close to ANOVA. From the perspective, it's testing more than two groups at once. Kruskal-Wallis test is used for ordinal types of data, or for interval or ratio types of data if they are shifted or transferred into ranks. So the uses of Kruskal-Wallis are either for ordinal types of data or if the data are not normally distributed. Let's explain the process of calculating Kruskal-Wallis test through example. Assume that a company interested to measure the employee satisfaction across different nationalities. Assume that sample collected and the results of these surveys are presented in this table. The first step is to rank all results in all groups. We started by 1 for the lowest reading, and 2 for the next, and so on. The lowest reading here in all groups is 65. So we assign 1. The next reading is 66. So we assign 2. The next will be 73. So we assign 3. Then 74. So we assign 4. And the next reading is 77. So we assign 5. The next reading is 80. However, this reading is repeating in 2 locations, and theoretically, one should be ranked as 6 and the other as 7. In such case, we give both the same ranking of 6.5 for both. Then we start from 8, as rankings of 6 and 7 both were given 6.5, and then we continue normally till we finish all cells. Then we need to calculate the sum of the ranks and the average of ranks in each group. So the first group, the total or the sum of the ranks will be 71.5, and divided by 6 will give an average of 11.91. For group B, the sum of the ranks is 35, and the average is 5.83. And for group C, the sum of the ranks is 64.5, and the average is 10.75. Now we calculate the total group ranks and the total group average. For the total ranks, we sum all group ranks, and this will result in total of 171, and dividing this number by 18, which is the total number of cells or reading we have, and that results in an average ranks of 9.5. The same result of average ranks could be extracted by sum all of the average and divide by 3. Then we need to calculate the difference between groups. So for group A, we multiply the number of readings or cells, which is 6, by the difference of average ranks for the group minus the average ranks for the total group square. And this will result in 35. For group B, 6 multiplied by 5.83 minus 9.5 to the power of 2, and that will be equal to 81. And for group C, 6 multiplied by 10.75 minus 9.5 to the power of 2, and that equal to 9. The total difference between the groups is 125. This value is denoted as SSPG. Then we need to calculate the H value using this equation, where all variables in this equation is known. SSPG is calculated as 125, and N is the total number of cells or readings, which is 18. Plugging the numbers in the equation will result in 125 divided by 28.5, and that equal to 4.4. Then we need to compare the calculated value with the table value. We compare the H value with chi-square table. Assuming we use confidence of 95%, then we are looking at this column of the table. To determine the row or the degree of freedom, which will be the number of groups minus 1, which will be 2. So we are looking at the second row. This table value is 5.99. Since our calculated value is lower than table value, 4.4 compared to 5.99, then we cannot reject null hypothesis, which means we have to accept null hypothesis saying that there is no difference between the groups.